So in the last video, we have learned how can we traverse and reverse traverse through a circular double linked list. Now in this lecture, we will use traversal to find a given node in the circular double linked list. So let's say this is our sample circular double linked list. The idea is same as we did in traversing a circular double linked list. We start loop from the head until we reach the last node in our circular double linked list. But here, in each case, we are checking that if this is the node that we are looking for or not. If this is the node, we terminate our loop and we return the value of node over here. If it is not, we will continue to check until we reach the last node. And when we reach the last node, and if we cannot find the node that we are looking for, we are returning message saying that the node does not exist in circular double linked list. So here, for example, if we want to search for a value of 4 over here, we start from the first node. So we are checking the value of first node if the value of this node equals to 4 or not. We see that it equals to 1. So we continue to traverse to the next node. So when we reach the next node, once again here we are checking if the value of this node equals to 4 or not. And we see that it is 2, so which means that it's not 4. So we continue to the next node. So here again we check if the value of this node equals to 4 or not, and we see that it's not equal. Then we continue to the last node. So when we reach this node over here, we see that the value of this node equals to 4. So this means that we terminate our loop over here and returning the value of this node over here. Now let's see how does the algorithm of this searching a node in circular double linked list look like. So the algorithm is like this. It starts with parameter, which is node value. This is the value that we are looking for. Then the first step is we are checking head value. If head points to none, we terminate our algorithm. It means that we don't have any element in our circular double linked list. Otherwise, we continue to loop through circular double linked list, and in each step we are checking if the node value equals to the current node value. If it is, then we terminate. If it is not, then we continue to loop. And in each case also we have another condition. We are checking current node's value if it is equal to tail or not, because by doing so we are preventing infinite loop. So as the last node points to the first node, so if we don't put this condition over here, searching process will be infinitely. So to prevent this case, we need to check current node's value. When we reach the tail, which is the last node, we need to terminate our loop. So this is the algorithm for searching in circular double linked list. Now based on this algorithm, let's create our search method in circular double linked list. So let's switch to Visual Studio Code and create a method over there inside circular double linked list class. So here again, inside circular double linked list class, we will create a method after reverse traversal method. So our method will be search circular double linked list. So we know that default parameter is self, and it will take another parameter which will be the node value. This is the value that we are looking for in circular double linked list. So the first case according to our algorithm is to check head value. So if self head is none, we return saying that there is not any node in circular double linked list. Otherwise, we continue to loop through circular double linked list. So we know that to loop through linked list, we need to create temporary node over here and assign head value to it, which is first node. Then inside while loop, we are checking for the value that we are looking for. So if temp node value equals the value that we are looking for, which comes from the parameter node value, then we return temp node value. Then inside loop, we need another condition which will check if this node is the last node or not. For checking this case, we will write another if condition. So if temp node equals self dot tail, we will return saying that the value does not exist. The value does not exist in circular double linked list. So then we are setting temp node to temp node dot next, because in each case we are traversing to the next node. So we are writing this if condition over here to prevent infinite loop. We know that the last node in circular double linked list points to the first node, so when we reach the last node we have to stop the loop over here. Otherwise it will continue to the first node, so infinite loop will occur over here. So to prevent this case, we are putting this if condition over here. Now our method is complete. Now let's run our code and see how this is working. So here again we have created circular double linked list with one element. Then we are inserted 3 elements to it. Then we are printing the circular double linked list over here. Now here I will run search function. So I will search for the value of 2. So we know that we have value of 2 in the circular double linked list. So I will search for it. So to see if our method works correctly. So let me print out this value over here. Okay, let's save and run our code. You see that our circular double linked list is like this, and it's returning 2, the search function over here, which means that 2 exists in our circular double linked list. Okay, if I put, for example, different value over here, let's put 6. It should return the message that the value does not exist in circular double linked list. So let's run our code. You see that in this case it returned message saying that the value does not exist in circular double linked list. So our method works correctly. Now let's see what is the time and space complexity for this method over here. So once again we start from the first line of code. So here we are checking head value and returning message, and we know that this is O1 time complexity. Then in the else condition we are creating temporary node and assigning head value to it, and this is also O1 time complexity. Then here we are looping through circular double linked list. This is ON time complexity. So then inside loop we have 2 if conditions. So these if conditions over here takes O1 time complexity, and assigning temp node to the next value of temp node is also O1 time complexity. So if we combine everything for this loop over here, we are getting ON time complexity, because these O1 time complexities are non-dominant terms. So searching for a node in a circular double linked list take ON time complexity in the worst case, because the node that we are looking for might be at the end of circular double linked list. This means that we need to traverse through all elements of circular double linked list. So this takes ON time complexity. Now the space complexity is O1, because here we are just creating one temporal node over here, which takes O1 space complexity. So space complexity for searching in circular double linked list is O1. Now this is all for this lecture. So in this lecture we have learned how can we search for a node in circular double linked list, and we have learned what is the time and space complexity for this method over here. Now in the next lecture, let's see how can we delete a node from circular double linked list. So see you in the next lecture.